are here. So what is our problem? Our problem was to calculate the coefficients of the Taylor polynomial. It is the Taylor polynomial of the fourth degree for f of x equals x cubed, centered at a negative 2. We are provided the formula to be using. So this is our fourth degree Taylor polynomial. And I presented my answers, which include the coefficients for the Taylor polynomials and whether or not they are equal. So, given the problem and the values that we are given, f of x equals x cubed, centered at a equals negative 2. Using the provided fourth degree Taylor polynomial, we can reconstruct this formula to better fit and understand what we have to do. So, the coefficients essentially mean our zeroth coefficient is going to be f of negative 2. Our first coefficient is going to be the derivative of f of negative 2 divided by 1 factorial. This is to the power of 1, so we don't have to write anything here. So our second coefficient is going to be the derivative of our first coefficient. Not our first coefficient, but the derivative of f of x. And that's negative 2, f of negative 2, divided by 2 factorial. And this will be to the power of 2. Plus the derivative of the derivative of the derivative of x cubed, where x equals negative 2, divided by 3 factorial. The numbers next to it will be cubed. Since we are following the fourth degree Taylor polynomial, same can be said for our fourth coefficient, which will be the derivative of the derivative of the derivative of the derivative of f of x. So we are evaluating this derivative on negative 2 divided by 4 factorial. Next to it, x plus 2 to the power of 4. So what is our first step? We should evaluate all the derivatives. So what did we end up doing? What I ended up doing was, first off, we have our f of x, f of negative 2, which is x cubed. Then, of course, we plug in our negative 2 to get negative 8. We go ahead and substitute this back into our equation. Then we get the derivative of f of x. Plug in the negative 2 instead of the x, where we would get 3x squared, and do 3 times negative 2 squared, which is equal to 12. So afterwards, we get the derivative of 3x squared, which would be 6x. We plug in the negative 2 where the x goes, so we get 6 times negative 2, which is equal to negative 12. Now, afterwards, we get the derivative of 6x, which is just 6. There is no numbers that can be put in here, for there is no x. The derivative of 6 is 0. This applies for all constant numbers. So now that we have all the derivatives, as well as all the values for our derivatives, we can go ahead and plug this back into our equation, where we would get C0 is negative 8, C1 is 12, C2 is negative 12 divided by 2 factorial, which is 2. So negative 12 divided by 2 is negative 6. Then we get C3, which is supposed to be 6 divided by 3 factorial. 6 divided by 3 factorial is 6 divided by 6, because 3 factorial is equal to 1 times 2 times 3, which is 6. 6 divided by 6 is 1. C4 is 0. So what we do is we evaluate this equation and we begin to simplify it. Let's start from the right and then go our way towards the left. So from our right, we have 0. 0 times anything is 0. Following, x plus 2 cubed is x cubed plus 6x plus 12x plus 8. Oh, my bad. I meant to put 6x squared. This is a mistake. Following, we have negative 6 times x plus 2 squared. We get negative 6x squared minus 24x minus 24. Following, we get 12 times x plus 2, which is 12x plus 24. Afterwards, we get negative 8. We evaluate this. Negative 6x squared plus 6x squared equals 0. Then we have negative 24x plus 12x plus 12x equals 0. Negative 8 plus 8 equal to 0. 24 minus 24, 0. That leaves us with x cubed, leading us to believe that x3 is equal to its polynomial at the fourth degree Taylor polynomial, centered at a equals negative 2. So this is why we got these answers. All the answers correlate, as can be seen. We have negative 8 for C0, 12 for C1. For C2, we get negative 12 over 2, which is what I put. Negative 6 also works, but I decided to do this just for my convenience. C3, which is 6 divided by 6, is equal to 1, just as it is here. And C4 is equal to 0, just as it is here, following all the work that we had done. So, in the end, the function f of x equals x3 does equal its fourth degree polynomial, Taylor polynomial, centered at a equals negative 2. We were able to prove this by plugging in all the numbers we had calculated back into the Taylor polynomial, simplifying the equation, and receiving x cubed. You can also graph, and you'll find that the numbers are the same. Better yet, the lines are the same. I have now presented my solution for problem 4 of 1.2 Taylor polynomials. I will elaborate that for Taylor polynomials, you do derive continuously after the previous step. So for our first step, we don't do a derivative. For the next step, we do a derivative divided by 1 factorial, with next to it a factor to the degree of 1. Plus, we derive it again, now divided by 2 factorial. This would be the second degree, then the third, then the fourth. And it follows like that respectively. Thank you for your time.